Imagine for a second that you need to send an email to a friend on the other side of the world.
Right.
You type it out, you hit send, and you never once think about how it actually gets there.
Yeah.
I mean, if a server in London suddenly goes offline, the data packets just seamlessly reroute through, Frankfurt or Tokyo.
Yeah, your message arrives instantly, no matter what.
Exactly. We expect that kind of miraculous, redundant resilience for everything digital. Our text messages, our cat videos, our financial data. But what if we could send physical, highly volatile matter, like millions of barrels of crude oil or natural gas around the globe, exactly the same way?
I mean, it sounds like pure science fiction, honestly. Whenever we picture global energy transport, the image that comes to mind is massive, rigid steel pipes buried in the dirt.
Yeah, just moving liquid in a straight line from point A to point B.
Exactly. It is an entirely linear process. So trying to route physical matter the way we route digital data completely breaks our conventional understanding of global infrastructure.
Which makes this such a fascinating concept to explore. Welcome to today's deep dive. We are unpacking a highly detailed storyboard that outlines a framework developed by concept designer Ali Hökerek. It's called the Global Energy Corridor System, or GECS for short.
GECS.
Yeah, our mission for this deep dive is to figure out how this framework proposes a fundamental redesign of global energy security. We're looking at a shift from relying on vulnerable, static physical pipelines to creating what the framework calls an Internet of Energy.
And the most compelling premise of this entire storyboard is what it doesn't focus on. I mean, this is not about discovering some revolutionary new energy source.
Right.
It totally ignores the debate over finding more oil or manufacturing better solar panels. Instead, it looks at the board and says the real vulnerability is how the energy we already have moves across the map. It proposes completely reimagining the transit itself.
Okay, let's unpack this. Because to grasp why an Internet of Energy might be necessary, you first really have to understand just how dangerously broken our current system is.
Oh, it's terrifying.
It is. If you're picturing a world map right now, you might not realize that the global energy network is, it's terrifyingly fragile. We are living in an era that relies almost entirely on single, narrow passages.
Yeah, the legacy infrastructure moving the world's economy was built for a completely different century. It's incredibly linear, which makes it incredibly vulnerable. To put a hard number on this, and this is a statistic from the storyboard that genuinely keeps policymakers awake at night, approximately 20% of the world's oil flows through one single narrow choke point.
Wait, 20%?
20%. Through the Strait of Hormuz.
Wow. So a fifth of the lifeblood of the global economy is all squeezing through a geographical bottleneck that is, at its narrowest, just over 20 miles wide?
Just over 20 miles, yeah. And that narrowness creates a massive cascading global threat. I mean, we've seen what happens when supply chains get blocked.
Oh, right, like that giant container ship in the Suez Canal a few years back?
Exactly. Global trade lost billions of dollars a day from that one ship. Now, apply that fragility to the world's primary energy supply. If the Strait of Hormuz is severed by, say, a geopolitical conflict, a natural disaster, or a targeted attack, the consequences aren't just local.
The oil prices would instantly spike globally.
Instantly. Supply chains collapse because the fuel needed to move goods is suddenly just gone. You are looking at an immediate global economic crisis stemming from a 20-mile stretch of water.
It's like having a massive overflowing water reservoir, but your entire town relies on a single easily kinked garden hose to get their water.
That's a great way to put it.
Right. Water sitting right there. But if someone steps on the hose, the whole town goes thirsty in hours.
And that analogy gets right to the core philosophical insight of this storyboard. The fundamental crisis of global energy is actually a transportation problem. We have the energy, but single points of failure threaten absolutely everything. When a nation relies on a choke point-dependent system, it isn't just importing oil, it is importing extreme geopolitical risk.
So if the garden hose is a terrible idea for the town's water supply, we have to talk about how we actually fix the hose. How do we move away from this single-line era? This brings us to a massive paradigm shift in the GECS architecture. We have to change the very dimension of how we view energy transport, moving our mindset from pipelines to packets.
Right, and the storyboard illustrates this shift by comparing the legacy system to the GECS framework across a few different dimensions. Currently, our topology is a single-line approach, one big pipe.
Right.
The GECS framework shifts this to a distributed network. So the vulnerability of being choke point dependent is replaced by being multi-route resilient.
Okay, that makes sense.
And instead of being static and rigid, the system becomes dynamic and fluid.
All of which fundamentally changes the focus of the infrastructure itself.
Yeah.
I mean, we move from being pipe-focused to node-focused. A node being a point of intersection, right? Like a place where a decision can be made.
Exactly. Shifting from a pipe focus to a node focus changes absolutely everything. If we connect this to the bigger picture, the legacy system worries about protecting one long, vulnerable tube. The GECS architecture manages a web of interconnected options. The solution isn't just bypassing existing lines by building redundant ones. It's about interconnecting them so that energy flows with the redundant resilience of internet data.
Okay, hold on. I have to push back here because this is where the concept starts to feel a bit abstract to me.
Sure, go for it.
I understand how data packets bounce around Wi-Fi networks and fiber optic cables. Data is weightless, it's just code.
Right.
But we're talking about millions of gallons of highly flammable physical liquid, millions of tons of steel. How do you actually build an internet out of physical steel and ocean? Taking a concept like data routing and applying it to a physical barrel of crude oil seems mechanically impossible.
It does seem crazy, but the storyboard addresses that exact skepticism by breaking the construction of the GECS into 5 distinct physical layers. The brilliance of Layer 1, the foundational infrastructure, is that it doesn't require us to bulldoze the world and build an entirely new grid from scratch.
Oh, really? It's not a tear down and rebuild.
Not at all. It's essentially a massive recycling project for global infrastructure. The framework starts by conducting rigorous capacity analyses of the legacy assets we already have in place.
So existing pipelines, massive storage facilities, export ports, local terminals, that sort of thing.
Exactly. Currently, those assets operate in total isolation. A pipeline runs its specific route, a port serves its specific fleet of ships. Layer 1 takes those isolated, sometimes underutilized assets and logically maps them to serve as network nodes.
I see.
So GECS is designed as a superstructure built on top of the world's existing infrastructure, which, saves trillions of dollars in capital.
Okay, but if we're recycling existing local roads, how do we connect the continents? Where do the physical superhighways actually go to tie these nodes together?
That requires Layer 2, the physical backbone. The storyboard outlines 3 massive, distinct global arteries. First, you have the North Corridor, which routes energy from the Gulf region up through Iraq into Turkey and directly feeds the European markets.
Okay, let's pause on that North Corridor for a second, because anyone who follows geopolitics knows that running a seamless energy superhighway through Iraq and Turkey involves a staggering amount of diplomatic friction.
Oh, absolutely.
I mean, the security hurdles alone are massive.
They are, which is exactly why the redundant corridors are necessary, because simultaneously you have the West Corridor pulling energy from Saudi Arabia, routing it across to the Red Sea, granting access to global markets.
Okay.
And finally, the South Corridor, originating in the UAE and Oman, pushing it out into the open ocean to feed the massive demand in Asian markets.
So we have our local roads mapped, and we have 3 continental superhighways built. But having 3 highways is completely useless if you can't switch between them when a storm hits.
Right.
So what acts as the traffic interchange? Like, how does physical liquid actually get off a local road and onto the right highway?
Now we move to Layer 3, the offshore router. At the absolute mechanical core of the GECS sits a marine-based main energy hub.
A marine hub.
Yeah, think of a massive, sophisticated structure sitting out in the open water. Its function is to operate exactly like a digital internet router, but for physical energy.
Right.
It connects all those global corridors, manages offshore storage, and physically redirects the flows dynamically.
Oh, wow. And this is where Layer 4 comes in, which the storyboard calls omni-channel integration.
Yes.
Actually, I'm going to use an analogy here for you listening. If you picture a modern, highly automated Amazon fulfillment center, you have massive conveyor belts bringing in boxes, robotic arms sorting them, and then different delivery trucks taking them out. The offshore router is like that fulfillment center, but for liquid energy. The pipelines are the conveyor belts, and the massive ships are the delivery trucks.
That captures the mechanism perfectly. What's fascinating here is that, historically, the energy sector has operated in very strict silos. The people who manage physical pipelines rarely integrate seamlessly with the people who manage marine shipping.
They just don't talk to each other.
Exactly. But the offshore hub forces them together. Physical pipelines, marine transport vessels, and LNG ships are all seamlessly integrated.
Now, let's clarify that for a moment, because LNG liquefied natural gas requires a massive physical state change.
It does.
You're talking about taking natural gas from a pipeline, supercooling it to hundreds of degrees below zero until it becomes a liquid, pumping it onto an LNG ship, and then having a marine hub that can somehow receive that liquid and integrate it back into a gas pipeline grid.
The engineering required is monumental, no doubt. But that is the exact function of the omnichannel hub. Energy can be instantly transferred between different transport mediums.
It's totally fluid.
Completely. Oil coming in through a pipe can be quickly loaded onto a marine transport vessel. Gas offloaded from an LNG ship can be regasified right there and pumped into a pipeline. It makes the system officially multi-route.
Right, so if a pipeline further down the network is compromised, the energy doesn't just sit there bottlenecked.
Nope.
It's transferred at the hub to a ship and sent via a completely different corridor.
Exactly. But there is still one major vulnerability to address. You have the roads, you have the ships, and you have the massive offshore router hub to switch lanes. But human latency is a massive problem.
What do you mean by human latency?
Well, the time it takes for a team of people to realize there's a crisis, hold an emergency meeting, assess the geopolitical threat, and manually issue the orders to flip the physical switches. It's just too slow.
Oh, right. If a major pipeline is attacked, and you have to wait for 3 different national governments and a corporate board to agree on how to reroute the oil.
It takes days.
Yeah, the global market has already crashed by the time they even draft a press release.
Yeah.
The panic buying is already set in.
Exactly. To truly act like the internet, the routing has to be nearly instantaneous. That introduces the brain of the entire framework, layer 5, the AI nervous system.
Okay, but you might be wondering, and I am too, AI is software. How does a piece of software physically turn a massive steel valve in the middle of the ocean? Or how does an empty 500,000-ton tanker just happen to be waiting at the hub to catch millions of barrels of rerouted oil?
That's the crazy part. The physical execution relies on a massive Internet of Things, or IoT network. Every valve, every pump, and every storage tank in the GECS network is motorized, sensor-equipped, and digitally connected to this central AI nervous system.
So the AI is actually in control.
Yes.
Yeah.
The AI isn't just sending an email to a human operator suggesting a change. It is digitally actuating the physical valves itself.
Wow, and as for the ships, how are they just there when you need them?
That comes down to predictive staging. The AI monitors 3 massive, constantly shifting variables. The first is demand analyzed, which is real-time tracking of global market requirements.
Makes sense.
The second is capacity monitored live volume tracking. The AI knows exactly what percentage of pipeline capacity is being used and where every single ship is located at any given second.
But it's the third variable that answers the staging question, isn't it? Risk assessed.
Yes, exactly.
Because the AI isn't just looking at the weather. It is continuously monitoring geopolitical and physical threats in real time.
It's analyzing troop movements, diplomatic breakdowns, seismic activity, social unrest. If the AI calculates an 80% probability that a specific choke point might be blockaded next week, it doesn't wait for the blockade.
It just moves.
Right. It proactively stages empty marine transport vessels at the offshore hub before the crisis even happens.
So it has total predictive situational awareness. The storyboard actually gives us a stress test scenario to illustrate exactly why removing this human latency matters. It compares a legacy collapse to a GECS response.
Right, let's walk through that. In a legacy system, let's say a hostile actor blockades a critical strait, or a catastrophic failure takes out a primary pipeline. The flow simply stops.
The bottleneck chokes.
Exactly. Panic ensues, supply chains freeze, and the global market crashes.
But in the GECS response, the AI nervous system detects the blockage or even predicts it instantly. It doesn't wait for a committee. It automatically diverts the physical flow away from the blocked north corridor and seamlessly pushes it across the west and south corridors using the omni-channel offshore router and those pre-staged ships.
And by eliminating human latency, the system turns what would have been a catastrophic global market crash into a minor background logistical hiccup.
That's wild.
The end user in Europe or Asia won't even notice that their energy just took a completely different path across the globe to reach them.
You know, think about the last time the GPS on your phone automatically rerouted you around a massive traffic jam. You didn't do a thing. You just kept driving, and the software quietly saved you 3 hours of gridlock. Now imagine that exact same automated, seamless rerouting, but on a global geopolitical scale involving the world's energy supply.
It is a phenomenal feat of systems engineering. Combining the physical offshore routing hub with predictive, AI-driven digital management reframes the entire conversation around energy security. We move from a posture of defense, guarding a single vulnerable pipe, to a posture of absolute agility.
Which brings us to the biggest aha moment of this entire deep dive. We started by looking at the terrifying fragility of the Strait of Hormuz, where 20% of the world's oil is held hostage by geography. We've walked through a blueprint that transforms that single point of failure into a node-focused, AI-driven, multi-route web. But the implications of this go so far beyond just keeping gas prices stable.
Oh, absolutely. This raises an important question. If the global energy corridor system perfectly secures energy by effortlessly routing around any physical or geopolitical threat, we have to look at how this completely redefines the power dynamics of nations on the world stage.
Right, let's really dig into that for a second. Think about the countries whose entire global leverage, their entire geopolitical weight, has historically been based solely on controlling a narrow geographical choke point.
The Strait of Hormuz is bordered by Iran on one side and the UAE and Oman on the other, or you have the Strait of Malacca, a critical shipping lane between Indonesia, Malaysia, and Singapore.
Right.
For decades, the ability to threaten those specific waterways has provided certain nations with an outsized voice in global diplomacy.
It's essentially do what we want, or we close the strait and crash the global economy. It's the ultimate trump card. But if GECS creates a geography-independent energy grid, does that mean the end of geographic monopolies?
I mean, it neutralizes the power of geography entirely. If a country threatens to turn off the tap or blockade a strait, the AI simply actuates the IoT valves, loads the energy onto pre-staged ships at the offshore hub, and sends it down a different corridor.
So the threat just evaporates.
The threat becomes meaningless. The entire global balance of power shifts overnight because the leverage of location is gone.
The power of geography is suddenly neutralized by the power of the network. A country can't hold the world hostage if the world can just automatically route around them. There's a quote from the Storyboard that I think perfectly encapsulates everything we've explored today. It says, "This is not a pipeline project. This is the Internet of Energy." And the core promise of the entire framework comes down to 8 words. The system does not stop. The system changes direction.
It leaves us with a profound reality to consider. We spend so much time worrying about who controls the map, but frameworks like GECS suggest that the future belongs to whoever builds the network that renders the map irrelevant.
That is a massive thought to chew on as we wrap up. What happens to global diplomacy when geography no longer dictates destiny? You've definitely given us a lot to think about today. Thank you for joining us on this deep dive into the Internet of Energy. Keep learning, keep questioning, and we'll see you on the next one.